So number one asks us to put these guys in order from least to greatest. So what I actually did is I drew 0, pi over 2, pi, 3 pi over 2, 2 pi. So after I get my quadrantal angles drawn, I'm going to kind of look at where do these exist on here. So let's start with sine of pi because that's my easiest. I'll color him yellow. Sine of pi, you know, is going to be right there. Sine of pi on 0, and the sign of my pi value is 0. So remember, here's 0, here's positive 1, here's negative 1. So sine of pi lies right here. Sine of 2 pi over 3, let's give him a different color, green. I know that 2 pi over 3 is going to lie somewhere within quadrant 2, and I also know that that's going to be a third away. So 2 pi over 3, if this were a unit circle, would be right there, right? So there's my pi, there's 2 pi over 3. So if I look here, I know that that's going to be very close to positive 1, and that is root 3 over 2. So let's just write this down. Root 3 over 2, sine of pi is 0. Next one, let's do 15 degrees. So 15 degrees is not on my unit circle, but I know where 30 degrees is, and 30 degrees is going to be right, if I'm looking at my circle, 30 degrees is right here, so I know that 15 is going to be right there. So pretty close to 0, but a little bit above. So far we have sine of pi is our smallest, then sine of 15, then 2 pi over 3. Sine of pi over 6, I know that pi over 6 is going to be 30 degrees, so let's color this. Let's do pink. And if I look at where that is, I know that this is 30 degrees, right? So I know that 30 degrees goes right here. And I also know, or pi over 6, that this value is going to be 1/2. So sine of 15, I don't know an exact value here, but I know it's somewhere between 0 and 1/2. So from least to greatest, I start off with my smallest value, which is sine of pi, because 0 is my smallest value. Then I have sine of 15 degrees. Then I have sine of pi over 6, and then my largest value in this list is sine of 2 pi over 3. Put a box around it. Convert 125 degrees to radians. Remember that I want to go 2 radians, so I'm going to be using pi over 180 degrees. So I'm going to say 125 degrees. I want those degrees to cancel out, so working through here, degrees cancel. I'm left with 125 pi over 180, and I'm going to simplify this by dividing both of those by 5, because I know very clearly that both of these are divisible by 5. So I get 25, and then 180 divided by 5 gives me 36. That seems like that's as far as I can go because I do not see another GCF. So I'm going to leave this 25 pi over 36 radians. Number 3 lists 3 other angles in the degrees that have the same reference angle as 135. I know that reference angle is closest x-axis. 135 has a reference angle of 45 degrees. So I just need to figure out what are 3 other angles that have the same reference angle. I know, first off, that 45 degrees works. I also know, I could do a little better job here. I also know that 45 more than 180 works, which is 225. And then I know that 45 less than 360, or 300, and 15. We also could have added, so these are just 3. You could have also done a number of things here. I could have said, what is 135 plus 360? Because that would put me all the way right at that same value, even though it's technically like a different angle. So I could have said, okay, this also could be 495. Or 135 plus or minus 360. Any iteration of that. Last but not least, given the ordered pair, 5/7 and negative square root of 2, 5 that lies on the terminal side of theta, what is the value of cotangent? So I know that cotangent is 1 over tangent of theta, 1 over, or cosine divided by sine. I know that my cosine is my x value here, and I know that my sine is my y value. So I'm just going to write this out horizontally now. So my cosine is 5/7, and I'm dividing by negative square root 2 over 5, which gives us 5/7 times 5 over negative square root 2. Flip and multiply there. So we get 25, or negative 25 over 2 root 7. Whoops, I did that wrong. Sorry about that, guys. I'm moving a little too fast here. 7 root 2. And then rationalize that denominator by multiplying by root 2 over 2. And I get negative 25 square roots of 2. Remember, it doesn't matter where the negative sign goes. The whole thing's technically negative. Over 14. Box that. So I'm going to say cotangent of theta equals that. And we are good to go.